So a couple of examples then of partial fractions when working with improper fractions. So the first thing is to identify the fact that we've got improper fractions, and in this case we've got our highest power of x on question 1 here is a 2, and if we expand the bracket on the bottom, the highest power is also a 2. So the division that we're actually going to be doing here is 2x squared minus 8x plus 10 divided by the denominator there, which comes to x squared minus 2x and minus 3. So using the box method then, we're reversing this division. So we're saying what do we times x squared minus 2x minus 3 by to give this polynomial, which was our numerator. So set up our box then for our multiplication. We don't, just change the colour as well so we can keep track of what we're doing. So we want a 2x squared in here. So what do we multiply x squared by to get 2x squared? We're going to multiply that by 2. So we've got a 2 up the top there, and then 2 times minus 2x there gives me minus 4x, and 2 times minus 3 gives me minus 6. So what I can say then, I can rewrite this original expression as 2, which is what the division gave us, plus whatever the remainder is. So looking at what we've got here, we've got minus 4x and we wanted minus 8x. So my remainder is a further minus 4x, because minus 4x minus another 4x minus 8x. Along with that, I've got minus 6. I don't want minus 6, I want plus 10, so I need to add on 16 to that. So, and then that is being divided by whatever we were dividing by before, this number here. And I'm going to go straight away and put that in its factorised form. So that's not the completed answer. That's not written as a sum of its partial fractions, but now it's no longer an improper fraction. The highest degree on the numerator is just a 1. Visible 1 there, and if we expand out the bracket there, the highest degree on the denominator is going to be 2. So we've no longer got an improper fraction, so we've actually just got a question similar to the ones that you would have seen in the previous videos and you'd have worked on. So I'm now going to just write this as a sum of its partial fractions. So this one reasonably straightforward, so it's minus 4x plus 16 over x minus 3, x plus 1. And that's going to be written as some number over x minus 3 plus a second constant over x plus 1. So I'm going to do this reasonably quickly. So this is going to be a of x plus 1 plus b of x minus 3. And all that's over the same common denominator as the minus 4x plus 16. So let's firstly let x equal minus 1. Which will eliminate my a term. So I've put minus 1 in here, and obviously you've got a calculator, so you can use your calculator should you wish to. I'm just going to do it without because it's possibly actually a little bit quicker. So I've got minus 4 times 1, which is 4, plus 16, which is 20, no a's, and minus 4 b's. So b comes to minus 5. And if I let x equal 3, I'm going to get minus 12 plus 16. By putting 3 into that one, the a is going to be 4a and no b's. So I've got positive 4 here and positive 4a, so therefore a must equal 1. So taking these two results of a is equal to 1 and b is minus 5, we can then go back up to here, this thing, and effectively what we've written below it. So what's now in the yellow box can be rewritten as two partial fractions instead. So we've got 2 plus, now a was 1, so 1 over x minus 3. Don't really need the brackets, but I'll put it in anyway. And then b came to minus 5, so subtract 5 over x plus 1. And that then is, I'm going to get rid of those brackets because they're not necessary and makes it a little more untidy. So we've now written that algebraic fraction, which was a top-heavy fraction or an improper fraction, as the sum of its partial fractions. I'm just going to, again, just clear all this, and we'll have a look at the second question as well, where the order of the numerator was more than the order of the denominator. Okay, so we're back again then, now looking at question 2. So this time the order of the numerator is a 3, and the order of the denominator is going to be a 2 with x times x. But again, it's the same process. So we're going to do x cubed plus 2x squared minus 2x minus 6 divided by the denominator. So x squared plus 3x plus 2. So this is what we're going to have on the outside of our box, x squared, 3x and 2. What do we times x squared plus 3x plus 2 by to get our numerator, sorry. So we want an x cubed in here. So I'm timesing by x. That's going to give me 3x squared and 2x. Now I don't want 3x squared, I want 2x squared. So I'm going to be subtracting a single x squared away, so that these two here add up to the 2x that I want. So what number is going to go above here? It's going to be a minus 1, which gives me minus 3x, and it gives me minus 2. So I've now got the division, the whole part of it, and now I just need to find the remainder. And the mistake that a lot of students make at this point is, what is the remainder to get to the minus 2x? We've got these two x terms here. So I've got minus 3x plus 2x, so I'm at minus x, and I want to get to minus 2x. So my remainder is a further minus x. Because if I've got 2x minus 3x and minus x, I get minus 2x. I'm also at minus 2 here, and I want minus 6, so a further subtraction of 4 is required. So my remainder and my division are sorted. So this now allows me to write x cubed plus 2x squared minus 2x minus 6 over x plus 1, x plus 2. That is written as the division itself, so what the result was, which was x minus 1, and then I'm going to add on as a fraction the minus x minus 4 over what we were originally dividing by of x plus 1 and x plus 2. Now I'm going to stop there, but what you may then need to do, which I did in the earlier example in this video, is then write this bit as a sum of its partial fractions. But I think you've seen enough of those now to know what to do from that stage. So when you've got an improper fraction, remembering it's the order of the top is the same or bigger than the order of the bottom, that is when you have to do a division before completing the partial fractions. If you don't do that division, the method doesn't work and you will not get the right answer.